Hi, everyone. I'm Plastics News publisher Brennan Lafferty. Plastics News is your organizer of the Plastics, Caps, and Closures Conference. This week, this conference offers more than 40 speakers in 18 different sessions. Welcome to Ask the Expert, our live stream series featuring the latest technology for the caps and closure market. With Ask the Expert, this is your chance to ask questions of industry professionals. Today, Ask the Expert will explore liquid color and associated cost savings. And our expert, Mr. Paul Maguire. Paul is president and CEO at Riverdale Global. Paul will answer questions after his presentation. If you do have questions for Paul, you can send them at any time to pnevents@crane.com. Or if you're watching this live stream on LinkedIn, Facebook, or YouTube, send your questions through those social media platforms. With that, I'll turn things over to Paul Maguire at Riverdale Global.
Thank you, Brendan. And thank you. Good afternoon, everybody. Hopefully today I can answer some of your, explain a little bit of the benefits of liquid color and answer some of your questions you may have. Before we get into that, I'll give you a little bit of background. On our next slide, we show the timeline of Riverdale Color, an old company, started late 1800s, developed liquid color in 1966, and also how we integrate with Maguire products. Maguire products started in 1977 and developed the first peristaltic pump for liquid color. So the two companies have been tightly connected for a long time until they have become financially connected around the turn of the century, 2000. So let's go on to the next slide and jump right into really one of the biggest benefits of liquid color: saving money, cutting your color costs in half. Okay, but before we do that, let's go on the next slide here and give a bit of a background first. What is liquid color? All right, so you have on the picture on your left there, dry color. That's the actual color itself. That's your pigment that goes to color your product. Now, traditionally, if you're using color in your process for caps or closures, you're probably using it in a pelletized form, which is what over on the right side, pelletized color. But liquid is taking that powder and dispersing it into some form of carrier system, some form of oil that can be metered into your process. Okay, the benefits here typically end up being dispersion and loading as well, but you can get that pigment dispersed much more quickly in the process. You don't have to wait for the pellet to melt before it actually starts to disperse. Okay, so let's go on to the next slide and take a look at an example here, just some numbers. Now, everybody's different on how much color spend you're using, but here's an example. That's if you're running an injection molding machine and you're saving and you're running 100 pounds an hour. This is assuming 6 days a week, 6,000 hours per year, and let's say you're running 10 machines. So if your usage is 3% in pelletized concentrate and your cost is say $3.50 a pound to color 100 pounds of product, versus liquid, you might be down at 0.9%. Okay. With additional costs there. We won't go through the actual numbers, but the math works out that it's about half. The reason that you can use a much lower letdown is because two reasons. One, the color is more highly loaded in the liquid form, but it's also because it disperses better, you can develop the same shade by using less pigment, significantly less pigment. So you have a lot of savings there in that way. Let's move on to the next slide here. So liquid color, cutting your costs in half by using it. But also there's other costs too. The annual cost, what is your annual cost of color changes? Let's take a look on the next slide here. And here's an example of pelletized color versus liquid color. The big thing with liquid is it changes over. It cleans out much faster than pelletized color. You're running at lower temperatures. There's less likely of the pigment to plate out, less for it to clean. And the carrier system itself acts as a little bit of a scrub, as a cleaner through there. So again, not going through the math, basically you have, though, a certain amount of savings of your resin that you're using to purge out. That's displayed there in the green. And you have a certain amount of machine time that's also displayed there. Now in this example, it's using resin at about $1 a pound and machine time at about $100 an hour. So that's where that's coming up with about a 50% savings across in that. Okay, so let's move on to the next slide here. And so there, you cut your color costs in half, decrease your color changeover time. Why pay more? Well, maybe you've heard liquid color can be messy. Maybe you used it in the past and maybe it was messy. Maybe you don't want to deal with the disposing of containers that are probably still coated with color in them into your trash. You don't want to deal with that industrial waste, that potential environmental issue. Liquid color can be messy, but with proper technology and proper handling, it can stay sealed. It can stay in the container, and the containers can be refilled. So let's move on, and we'll to the next slide here, and we'll take a look at a couple things here. One, how we make it. Okay. Now this is from a sustainability side. This is not so much in your plant, but we make it in sealed containers. We dedicate the containers to it so we don't have the waste, so that we're saving as well as not having to dispose of environmental issues by disposing of color. But a big point to liquid is, again, the dispersion. You can just see depicted here with the little green check mark. The pigment is going to disperse much better over the entire liquid and the pellets that it's coating, that you can use less of it to get the same coverage, whereas the pellet is going to have to melt and it's not going to be able to be, it's not going to have time to fully disperse without overcoloring. Also, a little benefit is making liquid. We use a lot less electricity than we do than you would in compounding pelletized color. So there's a nice feel-good factor there, sustainability factor there on that. Less cost going in to make the product and less energy going in to make it. Okay, on the next slide here. Now, how we meter it. This would be in your plant. For one, you're going to see savings on your amperage. Your amperage is going to drop because the liquid acts as a lubricant, as a flow modifier on your resin, on your polymer. So you get to lower your heats and move the polymer through with less effort. We've had customers document 16% savings average on that. And gravimetrically, metering it gravimetrically, you're going to see about a 10% savings on that. Typically, because if you undercolor, you will notice if you're undercoloring. So operators will turn it up and they'll slightly overcolor, so they don't have to worry about it. But gravimetric will keep it at the right amount, and so you're not over or undercoloring and benefiting some savings there. Okay, on to the next slide, please. And here, how we maintain. This is a big aspect of using liquid color, or in general using Riverdale liquid color. Return for refill. By refilling the containers, nothing goes into the local landfill or into your dumpster, or all over somebody's hands and shirts if they're told to open the containers and scrape them out and squeeze the bladders that are in there to try to get that money out. So you get a savings there. You get other savings on transporting the liquid. It's less weight. One pallet and less space. One pallet of liquid will about the same as about 5 pallets of pellet. So you have a lot less fuel going into transporting it and a lot less warehouse space needed to store it. Let's continue on to the next slide and take a look at PCR. A few examples here. Post-consumer regrind, big in caps and closures. Everyone is requiring, holding themselves to higher standards to say we use 20%, 50%, 75%, 100% post-consumer regrind in our product. However, post-consumer regrind isn't always the easiest to work with. You start losing some physical properties, you start losing dimension, strength, tensile strength. So it gets a little bit difficult. One advantage of using liquid is, we'll see on the next slide here, is that you can, we can use the liquid. The liquid itself is an additive, and it can act as the carrier for the pigment and also as an additive to increase the benefits. One particular additive we call Plus Restore, and this helps restore back some of the physical properties in the polymer. Let's move on to the next and look at some of these results here. On to the next slide. There we go. And here you have, this is done with polypropylene. We've done some things with polyethylenes as well in here. But you have your virgin PP elasticity and your regrind. And you can see by just putting in 0.4% usage rate of this Plus Restore, we are able to almost fully restore back the elasticity of the recycled polymer. Going on to the next slide, we can take a look at increased strength. Here we are actually able to, with the additive, go beyond virgin. So not only regain what we lost in the recycling, but we actually added some strength with the exact same additive here. The key, I lost my train of thought on that one. Oh, no, I know, 0.2%. This is just such a little bit going in here and adding a whole lot, and doesn't add as much to the cost because you put it in with your color. It takes away some of the carrier system. Okay, let's look at one more thing on this on the next slide. There we go. The lower scrap rates. Basically, this is looking at a lot of the notch izide, tensile, flex modulus, flex strength, looking at all the different numbers base versus the control. Now, this was a 3% post-consumer regrind white concentrate, where the Restore pretty increased across the board all the benefits of what you would want to see in that. Okay, on to the next slide here, and summarizing why Riverdale Global. On the next slide here, we list just a quick summary: cutting your color cost in half. Everybody loves that. Reduce coloring changeover times, reducing your energy, less warehouse for space conscientious, especially caps and closures. You can have lots of different colors that for all the different caps and closures. Having less space is a big saver there for some people. Zero waste, no landfill. I mean, that's the big thing. And it's becoming a bigger thing. What are you doing with it? Even if you're using pelletized color, there's still a lot of cardboard boxes and such that are going either to a landfill or to a recycling center, which is good, but reusing is even better than recycling. So return for refill. We refill the containers. You get rid of the mess. And a nice benefit is the carrier systems are plant-based. They're not petroleum. So there's a little bit there, a little less, a little more on the recycling, on the sustainability side. You can use 100% PCR in some cases. And what you see in this picture here is actually a local satellite where we can make the color, do the final blending close to the customer. We don't have all the heavy machinery. We make everything in single pigment dispersions, and you see them in all those drums there for making the final 1 gallon or 5 gallon or 30 gallon pail or container of color for the customer. All right, well, thank you for listening to that. Let's go on to the next slide there. A little bit of savings information, contact information, and let's answer some questions.
All right. Well, great presentation, Paul. Let's get to some of those questions. For those of you who weren't here at the top of the show, if you do have questions for Paul, send them through email at pnevents@crane.com, or if you're watching the live stream on Facebook, LinkedIn, or YouTube, send those questions through those platforms. All right, Paul, let's revisit the old reputation of liquid color. Messy, hard to clean. Is that still the case? And how specifically can that be mitigated?
Well, so yes, liquid's still liquid and color is still color. So if it gets out of its container and you get it on yourself, on anywhere, if you don't clean it up, it will be everywhere. Yeah. So but through our partnership with Maguire products, we develop equipment, connectors, seal containers. We've also, through Riverdale itself, developed a model of refilling the containers and keeping it so the customer doesn't have to open it. That has been one of the main issues with making a mess, is opening the containers.
Yeah, that made a lot of sense. Yeah, if someone's like, go tell Harry he's got to open that drum up and get out,
Yeah.
As you said, you didn't even say get out the color, get out the money that's in that drum.
Exactly. Well, that's why they would do it, right? Yeah. And also it lends itself to cross contamination. People and just, you don't want to open it. You'd rather, if you're making caps for Tylenol bottles, you don't want someone opening that container and squeezing into the next one. Who knows what they're doing?
Right. Exactly. Well, here's a question that came in through email. Mm-hmm. Can you comment, Paul, on finished part properties with liquid color versus concentrate? Interesting.
Yeah. So I would probably want to delve deeper into what they actually mean there, but I'll comment a little bit on what I think you can do. I mean, finished part properties. So physical properties such as gloss, color, dispersion issues. Every liquid can do what concentrate can do, especially in caps and closures. And in particular, it can do it better. You'll get rid of dispersion issues. You can add nucleating agents if you need that to the product. You can add a lot of different additives all on top of each other, all as sort of like this super pill, sort of that you're putting into the process to fix all different types of issues you may have, release aids, assembly aids, and you can. It's nice because they all go together, which is why we call them plus. So you can have your color plus your nucleating agent, plus glide, plus whatever we call all the different additives. They add all together.
Mm-hmm. Okay, and it sure sounds like you're saying there's no negative, there's no negative properties from using liquid color in the finished product.
No, and if I were to say one, I would talk about if you were trying to do a dark color in a very thin, like a film. If someone's trying to do a blown film and trying to do a very opaque, they need a lot of pigment in there. And therefore, they need a lot of liquid to carry it in there. And therefore, the liquid may get in the way of trying to make the film. Okay. In all other applications, liquid's fine.
Got it. All right, here's another question. Excuse me, another question that came through email. How do you restore properties of PCR, including AO in color?
So how do you restore properties? AO, I mean, I'm talking about antioxidants there. You do put antioxidants in to help gain back some of the physicals. When you compound and you send your color and not so much your color, but your polymer through high heat, you give it a heat history. You've essentially changed that polymer slightly. And then when you mold your part, you've given it another heat history. Mm-hmm. And then when you recycle it, you give it another heat history. You keep weakening the polymer until it won't really hold its physical properties. One liquid starts out with one less heat history. It doesn't go through the compounding aspect. Also, though, you can it's without saying really what it is. It's antioxidants, but as well as it's more than that. That you can rebuild back the things that bind the polymers together to give it strength. And to achieve elasticity and to achieve actually, what we discovered it almost by mistake by just pulling the sprues when we molding our chips and pulling the sprues off. Sometimes you should just break them off. Mm-hmm. Then we started not being able to break them off anymore, and we realized we were running a different type of carrier system, and we stumbled upon something there.
Okay, very good. Boy, Paul, you've hit on a hot topic here. A couple more questions here through email. Regarding PCR, we discussed strength properties being improved with polypropylene. What were the results with polyethylene? What were the results for the finished closures?
So on the third slide that I had shown there, that was all polyethylene, and that was actually with PCR. The first two was more in-house regrind, not post-consumer regrind, but in-house regrind, which was the polypropylene. The results were very similar in them. In you're going to some obviously were not as favorable, but they were still always improved, and it was nice to at least get some type of improvement. Now, we could get a lot more improvement if it wasn't FDA. So if you're looking for a closure that wasn't FDA, there's some other things you can put in there that will help regain that strength.
Okay. All right. Another emailed question. When Paul speaks about adding strength, is he talking about IV build at 0.2%? Or what is the measure of impact strength? Could he speak further about the specifics of plus restore?
So no, I'm not talking about IV like PET and building that back up, but I am talking about impact strength, tensile strength, flex modulus. So I'm talking about more your physical properties. I don't know if it's we could test it with the IV. I don't think we've done any tests with that. We have more information, more sheets, and actually results that have been done by outside testing labs that we could share if someone wanted to reach out to us to get into it. To speak further on the specifics, I think the time wouldn't allow for that, other than to say we've seen a lot of favorable results. It's not to say it's going to work everywhere and everything, but it works well in certain things.
Okay. Here's a question that's come through about the cost. Can Paul talk a little bit more about cutting my color cost by using liquid color? Because didn't he say liquid color costs more per pound than pellets?
Yeah, it does cost more per pound. Two things. So you can load it up more highly. It's more highly concentrated, so you can load it up. Therefore, there's more pigment in there, which is why it costs more per pound. But because you don't need as much pigment to develop the same shade, if you're looking for opacity, and that's all you're looking for, opacity, you're just talking, I just want white. Okay, it's probably not going to be in half at all there, because you really need that pigment in there for the opacity. You could probably still get by with a little bit less because you're dispersing it better. But if you're looking for, I need my brand recognition, whatever it might be, Coca-Cola Red as a trade that someone might say, I need it to look like Coca-Cola Red. You can get that same shade development with much less pigment, without seeing dispersion issues, without seeing flow lines. So that's a big area where you're going to see the cost savings.
Okay. The question here is, do molders and processors need less purging compound if they were to switch to liquid color?
Yeah, purging compound companies don't like liquid color companies. We're friends with them, but they don't need purging compound typically. The purging can go away. You switch. We've seen so many examples where this one company was making chairs, and they're not caps and closures, but they were making chairs, and they would take about an hour of purge, and then they would, when they would switch, like I said, they'd purge for an hour, they get someone else to start the machine back up. When they switch to liquid, for one, it's sealed connection. They just unclicked the one tube, clicked in the next tube. They didn't stop the process. They switched, worst case, 5 chairs molded, best case, 2 chairs molded. It just pushed the one liquid through, made good chairs until it made the new one, and then made 1 or 2 bad chairs, and then made another good chair. You see that a lot in all the examples.
Okay. So the liquid color is the purging compound.
It is the purging compound. Yeah, it just changes over. It doesn't get hung up in areas. Lots of times we start running liquid trials, we'll start purging out colors they ran the prior week, picking up spots that they didn't even purge out.
That's interesting. You said 1 pallet of liquid color is equal to 5 pallets of pellet color. Very significant. If someone hasn't used liquid color before, do you offer test runs so they can have a demonstration?
Yeah, absolutely. And that's, we do color matches, typically a free color matches, and we'll send out samples. We'll go out and run it for them, because lots of people aren't familiar with running the liquid. So we'll make a throat adapter so they can introduce the liquid into their process, and then that's the best way to see it, is just see some results.
Yeah, for sure. Well, Paul, here's another question from the audience. What's the current uptake in liquid color today? What was it maybe 5 years ago? Makes me think, where do you think it'll be in 5 years?
So I would say a current uptick in it is where it was, whether 5 years ago, 10 years ago, is people were using it to save money or solve a processing issue. More recently, brand owners are getting involved and saying to the processors, we want you to use liquid because of the sustainability nature of it, as well as the money savings on their part too. They know it saves money and they want to see that some of that savings passed back, but also more and more on the sustainability aspect of the industrial waste that can be created through other coloring methods.
Right. Yeah, that's interesting that you say that, because I was actually wondering that myself. There's all these big brands, Coca-Cola being one of them that you mentioned, that have these mandates. We're going to use X percentage of recycled content by a certain date in our product, but it's bigger than that. The sustainability.
Right. Exactly. Yeah.
So is Riverdale Global liquid color available in the U.S., in Canada? What's the range of your customers here?
Yeah. North America heavily, and also we have a place in the UK that we distribute through Europe out of our UK branch there. We sell a little bit into China, a little bit into some other places, but those are usually affiliated with a US company that is putting it over there. But North America and a little bit into South America, but easily Mexico, Canada, US, UK, Europe, Germany, all around there. Yep.
And is the same point true about the drum's empty, the bladders are empty, and then they're picked up and brought back and refilled? Or
mostly, yes. Certain countries, the container, the customer might say, we don't know what happens to our containers. Once they're empty, the employees take them. They're using them for rainwater. I don't know what they're using them for, but they're disappearing on their own. But yes, the same model works.
Okay. So here's a question from LinkedIn. Have you encountered screw slip during processing of liquid color?
Yeah, no, this is an old question, and still a new question in the sense. Screw slip, traditionally, when liquid colors were developed a long time ago, they were using surfactants as the main carrier system. Surfactants are still necessary to be in there because they help wet out the pigment and help with that, but you don't need as much in there. And the surfactants are basically like a soap. They actually introduce a lot of slipping. More and more carrier systems can be engineered or selected to be very compatible with the resins. So they incorporate right into the resin very quickly and don't ride on the outside of the resin, thereby creating a slipping motion.
Okay. All right. So it sounds like something you've heard before. So
yeah. And to add to that, we've metered liquid color in processes as high as 8%, heavily opaque, or actually in this case was heavily amount of UV for, like a 50-year life outdoor construction. Yeah.
Well, to our audience, thank you for all the wonderful questions. Paul, any final thoughts for our viewers out there?
Yeah. I mean, I would just say, with all the advantages in the carrier technologies and the equipment, liquid color is not something to be afraid of. Don't be afraid of the slip. Don't be afraid of the mess. If you want to take advantage of the savings, or if you're definitely having processing issues, liquid color is something to take a second look at.
Awesome. Well, if you have questions for Paul, please reach out to him by using the email address you should be seeing on your screen right now. There it is. Yeah. And Paul, thank you so much. I want to thank you for joining us today. Paul Maguire of Riverdale Global.
Thank you.
Our experts. Yes, indeed. And thank you, our viewers, for watching and attending today's session of Plastics, Caps, and Closures. Our next session in the conference begins at 2 p.m. Eastern and will feature a panel discussion on sustainability, like Paul was talking about, and closure development. It's part of a full agenda that features 18 conference sessions. Until next time, I'm Brendan Lafferty. Thank you for attending Ask the Expert with Plastics, Caps, and Closures, organized by Plastics News. Don't go anywhere. Stay tuned for a parting message from Riverdale Global. you.